Hello, PreCalc. It's the sad day lesson on Thursday the 18th. It's the last one for you, Alex. Very sad day. You know you're going to miss it. Please check in and watch the videos sometimes and think of us fondly. Alright, we're going to finish up with a couple problems to shore up for Alex on the final and for you guys later on your finals. And we're going to solve this equation. This equation is with an exponent, the variable's in the exponent. So we've got to get it down out of the exponent. Do you recall what tool we have in our pockets that will allow us to do that? So digging around in our PreCalc pockets, we pull out a logarithm, but not just any old logarithm. Because of this number here, we want a base 4 logarithm. Because anybody walking down the hall knows log to the base 4 of 4 to the x. And if we take the log to the base 4 on the left, we have to take the log to the base 4 on the right. It's only respectful. So now, what exponent? A log is an exponent. What exponent do I give 4 to get 4 to the x? I get the exponent is x. And that's why I did that, to get the x down where I could use it. And now I have this quantity, which I cannot put in the calculators that we have, but I can remember to change it to log base 10 of 14 over log both base 10 of 4, the upper minus the lower number, so to speak. You may also use ln, and either one will come out, both are on your calculators, and will come out to 1.9. You can always check your answer to those by putting it in. 4 raised to the 1.9 should give you something pretty close to 14. Alright, so keep that in mind and be able to razzle-dazzle me on the one on the final like that. Alright, simplify. I always hear the Holy Spirit when I see that word saying simplify your life. Put me in the center. That's the Holy Spirit speaking. What is log to the base 6 of 6 squared? We did a similar step up here where we noticed what exponent do you give this to get this? What exponent do I give this to get this? I give it the exponent 2. There it is, staring you at in the face. So, can you believe there's one on the final like that? Easy peasy. Alright, 8 raised to the log of the base 8 of 22. Similar but not exact. This one is, we're thinking about this logarithm. It's the exponent I give 8 to get 22. I'm not sure what that is, but it's somewhere between 1 and 2. Closer to 1, because 8 to the 1 is 8, too small. 8 to the 2 is 64, too large. So that logarithm is going to be somewhere between 1 and 2, closer to 1. I'm not sure what it is, but if I raise 8 to that number, you see we get 22. So think of it again. This is the number you raise 8 to get 22. I'm going to raise 8 to that. It is 22. Alright. So you can rejoice in those quick problems which will be on the final. Alright, let's look at a little more trig. And we have a y and an x and an r and a theta on this right triangle. And we know theta is 32. We know y is 6. And we want to find x. So, back in our pre-calculus pocket, looking around, and we find trig functions. So what trig function will involve this angle, which is known, this side, which is known, and this side, which we want to know. This is opposite, this is adjacent from the position of this angle, so we're going to use tangent. Tangent of theta is opposite over adjacent. So tangent of 32 is opposite y, known to be 6, over x. So now we have an equation we can solve, and we can solve that by multiplying both sides by x. It'll appear over here and disappear from here, and then divide by tangent of 32. When you take 6 and you're in degrees and divide by tangent of 32, you get 9.6. Alright, moving right along. We're going to solve a trig equation. And solve means find out what x equals so that this statement is true. Alright, we got fancier with our trig equations, but I'll just go with this for the final, this type. Alright, so to solve, we're solving for x. So we're trying to find x. So first of all, let's isolate sine x. So sine x by itself on the left will equal negative square root of 3 divided by negative 2, which is just square root of 3 over 2. So that's saying when you're looking for x, what angle has a sine of square root of 3 over 2? Alright, so we're going to look at the unit circle. This time there's no restrictions. It's not an arc sine situation. It's a solve this equation situation. So we want to find all the x's that have a sine of square root of 3 over 2. Square root of 3 over 2 is the second coordinate of the second coordinate. So we go over 1/2 here and up square root of 3 over 2. Second coordinate. So this is pi over 3. And we also find that it happens again over on this quadrant, where we have negative 1/2 up square root of 3 over 2. And so the answer here is going to be 2 pi over 3. 16263646, which is 2 pi over 3. Can't see that very well. I'll write it down here. So the first one was x equals pi over 3, and x equals 2 pi over 3. However, we remember from our study that there's such a thing as coterminal angles. So looking at this one, we could also, instead of stopping there, we could go all the way around and get another one. So we get that by adding 2 pi radians. That's one circle. But then we could go around again and again and again and again. So we go 2 pi n times, where it's understood that n can be any integer. So can we do the same thing with this one? Can we go around and around and around? 2 pi n it is. Alright, so this gets the infinite number of answers that solve this simple little trig equation. Alright, number 5, find the partial sum. So partial means we stop short of infinity. Where do we stop? Well, in this one we stop at 45. We know it's a sum because of that symbol means summation. And now we need to decide what formula to use, because I'm not going to generate 45 of these and add them up. So I need to know if it's arithmetic or geometric. So I'm going to generate a few of the terms. I start with the one indicated here, and I get 3 minus 2. Then I put in a 2, I get 6 minus 2. Then I put in a 3, I get 9 minus 2. And I put in a 4, and I get 12 minus 2, etc. So what has been generated here? I notice that to get from one term to the next, I'm adding a 3. So therefore, we call that arithmetic, when we're adding the same term to each term to get the next. So that points me to this formula, which is true for the arithmetic sequences. So when we make our cards tomorrow, make sure you have the geometric sums and the arithmetic sums, or commit yourself to memorizing those. So we want to sum up the first 45, and n is 45 terms. The first term is a 1, but what is the last term? Well, I didn't want to go out 45, but I know on the 45th term I'll be putting in 45 into that expression. So what is 3 times 45 minus 2? And hopefully that makes sense to you, that that's the last term. It comes out to 133. So when I plug all that in, I get 3015. And I am so happy with that. Alright, believe it or not, Alex Pooh, this is all we're going to do tonight. We don't want to tax you. We want to give you time to study the review sheets and look through your comp book and formula page and just bring it all home. Alright, with a little boo-hoo and a wipe of the eye, I say, carry on.